Hi, I'm your classmate, Jessica Collier, and this video is the last in our series of videos on motivation theories. This time we're talking about cognitive theory of multimedia learning. We'll discuss the details of cognitive theory of multimedia learning, including 3 assumptions, 3 memory stores, 5 processes, 5 forms of representation, 3 kinds of demands, and 3 learning scenarios. We'll wrap up the video with implications we can draw from this theory for designing instructional artifacts. So what is cognitive theory of multimedia learning about? It's an attempt to describe how people learn from words and pictures, and it tells us that multimedia instructions should be designed to guide appropriate cognitive processes during learning without overloading the learner's cognitive system. The actual definition given in the article says that it's a theory of how people learn from words and pictures based on the idea that people possess separate channels for processing verbal and visual material. Each channel can process only a small amount of material at a time, and meaningful learning involves engaging in appropriate cognitive processing during learning. As a side note, I thought it was interesting in the video interview with Dr. Mayer, he said that he considers textbooks with text and images to be multimedia. I never think of books that way, but I guess that's because by the time I got into instructional technology, we had moved into the digital age. Cognitive theory of multimedia learning is based on 3 basic assumptions about how the mind works. First, dual channels. This assumption says that humans have separate channels for processing visual and auditory information rather than the single-channel, unlimited capacity, passive processing system some designers might assume that learners have. Second, limited capacity. This one says that humans are limited in the amount of information that can be processed in each channel at one time. And third, active processing, which says that humans engage in active learning by attending to relevant incoming information, organizing selected information into coherent mental representations, and integrating mental representations with other knowledge. This theory says that the human information processing system has 3 memory stores: sensory memory, working memory, and long-term memory. Sensory memory briefly holds copies of incoming words and images. Working memory allows for manipulating selected incoming information, and long-term memory permanently stores organized knowledge. Much of what happens during multimedia learning takes place in working memory. I thought it was interesting that Mayer mentioned the mental conversion of a spoken word, such as cat, which might cause you to form a mental image of a cat. I learned many years ago that many people don't form actual images of items or concepts. When I was a teenager, I discovered that if I said the word apple, for example, to my mom, she didn't see one, she just thought about the meaning of it. When I think of an apple, I vividly see many apples in my mind. Red ones, green ones, yellow ones, maybe one has a worm. Just a ton of apple possibilities popping up in my mind as mental images. And it looks like I'm not alone in this discovery, because this image keeps resurfacing online on various social media platforms where someone says, "Close your eyes and imagine an apple. What do you see?" So, if you made it this far into my video, let me know what you see. Okay, let's get back on track. This theory says that there are 5 cognitive processes the learner has to engage in for meaningful learning to occur in a multimedia environment. These don't have to occur in a linear order, but the learner must coordinate and monitor them in some way. The 5 processes are selecting words, where the learner pays attention to relevant words in a multimedia message to create sounds in working memory. Selecting images, where the learner pays attention to relevant pictures in a multimedia message to create images in working memory. Organizing words, where the learner builds connections among selected words to create a coherent verbal model in working memory. Organizing images, where the learner builds connections among selected images to create a coherent pictorial model in working memory. And integrating, where the learner builds connections between verbal and pictorial models and with prior knowledge. There are also 5 forms of representation in this theory that attempt to describe the stage of processing. First, words and pictures are presented via multimedia. Then, in our sensory memory, we have acoustic and iconic representations, followed by sounds and images in our working memory. Then verbal and pictorial models, also in working memory. And finally, knowledge in the long-term memory, which the learner uses for guiding the process of knowledge construction. It may be stored in long-term memory as prior knowledge to be used in supporting new learning. One thing we should try to avoid when designing instruction is overloading the learner's working memory capacity. This theory says that there are three kinds of demands on cognitive capacity. Extraneous processing refers to cognitive processing that does not support the instructional goal and is caused by poor instructional design. For example, having an image on one page and the caption on another can cause the learner to look back and forth, which wastes cognitive capacity. Essential processing is cognitive processing aimed at mentally representing the presented material in working memory and is caused by the complexity of the material. Essential processing involves selecting relevant information from the presentation and organizing it as presented, so it results in the construction of verbal and pictorial representations in working memory that correspond to the presented material. And third, generative processing, which refers to cognitive processing aimed at making sense of the presented material. This processing is caused by the learner's motivation to learn. The example in the chapter says that when material is presented by a likable instructor, the learner may exert more effort to understand what the instructor is presenting. That's true in the workplace as well. Generative processing consists of reorganizing incoming information and integrating it with relevant prior knowledge, leading to the construction of an integrated mental model. And as a side note, each of these is relative to the learner and their interaction with the instructional situation. Learners differ in terms of their working memory capacity, so their ability to handle each of the types of demands will differ. A multimedia lesson may be overloading for one person and not for another because of differences in capacities, knowledge, skills, and beliefs. And one final point about cognitive capacity. It's limited and the types are additive, so if the learner increases one kind of processing, another must be decreased. The chapter we read by Mayer discusses three learning scenarios based on the model of cognitive processing demands. Those are extraneous overload, essential overload, and generative underutilization. Extraneous overload happens when the instructional message is so poorly designed that the learner is forced to expend large amounts of processing capacity on extraneous processing, leaving insufficient capacity for essential and generative processing. Essential overload happens when the material is so complicated that the learner doesn't have enough cognitive capacity to mentally represent it as presented. Essential processing is needed to mentally represent the to-be-learned material, so it's not appropriate to seek to reduce it. In the generative underutilization scenario, the learner has cognitive capacity available to engage in generative processing, but does not exert the effort to do so. The cognitive theory of multimedia learning suggests three primary goals of instructional design, which, by the way, help combat the previously mentioned learning scenarios: reduce extraneous processing, manage essential processing, and foster generative processing. For each of these goals, several techniques can be used. As seen on this table, there are several principles with a description for each technique. The techniques can serve as guidelines when designing instruction. The guidelines tell us to eliminate extraneous material and highlight essential material, not to add printed text to spoken text, which I've done several times in this video, to place printed text near the corresponding graphic, to present narration and corresponding graphic simultaneously, to break the presentation into parts, to describe names and characteristics of key elements before the lesson, to use spoken rather than printed text, to use words and pictures rather than words alone, to put words in conversational style, to use human voice instead of the robot voice for spoken words, to give on-screen characters human-like gestures, to provide hints and feedback as the learner solves problems, to ask learners to explain a lesson to themselves, and to ask learners to make drawings for the lesson. In summary, cognitive theory of multimedia learning tries to explain how people learn from words and pictures, and we can use the techniques given to reduce extraneous processing, manage essential processing, and foster generative processing to ensure that our learners are engaging in appropriate cognitive processing. Thanks for watching, and I'll see you all later.